Hey guys, let's look at the following. Other kinds of limits where we have a fraction.
And this one is very important because, listen, let's have a look at the slide quickly. Nelson, look at this limit. This is a funny looking graph. The limit is x squared minus 4 over x minus 2. If x goes to 2, what is going to happen?
Denominator is 0, and then that is not allowed mathematically.
In other words, it's division by naught. That's a huge problem.
It means we cannot start by replacing x by 2. We have to manipulate.
Absolutely. So let's have a look. What do you think we should do here, Nelson, on this thing?
Right. If you look at this, guys, the top one, it's a quadratic expression. If you factorize it, you simplify the whole fraction, then you get, look at this. The factorized form of the numerator is x plus 2, x minus 2 divided by that. And then this will cancel or will divide. Then you have this now, x plus 2 remaining. Now you can straight away replace x by 2. If you put 2 for x, then you have the limit of 4.
Okay, now that's all very well, hey Nelson. It's got, I mean, we factorized and of course the limit came out to be 4. But the problem is in the beginning with that funny looking graph, the limit, it wasn't possible to work it out. So I think, can we look at a little bit of an investigation as to what this really means, this whole concept? We're going to go to a bit of a sheet of paper here and have a look and see how this works. Okay, watch this, guys. Nelson, what is the graph originally? Do you agree that that graph originally looked like this? Okay, it was, in other words, it was x squared minus 4 over x minus 2. That was the original graph. Now, guys, that graph, they wouldn't know how to sketch, but let's factorize it and see what happens. What kind of graph do we get? Check this out if we go back. Now, Nelson, what would this be? What can x not be?
X can be 2.
So x can definitely not be 2. If we factorize it, let's see what happens. Okay, so we factorize that thing. Okay, and what's going to now happen?
Right, now you have x plus 2.
Just x plus 2. Now, what kind of graph is this?
This is the straight line.
It's a straight line. So if we draw that graph, let's just do it quickly here. If we draw the graph, this is very important for higher mathematics, but what would be the y-intercept of this graph?
Is 2.
Okay, so it's definitely cutting at 2.
Yeah,
okay.
X is negative 2.
So it cuts at 2 there, and if we extend it up a little bit, let's see what happens. Okay, I'm going to go all the way up to 4 there. All right, now, if you want the x-intercept, what is the golden rule there?
And then you put y0.
Okay, remember this guy's the y-intercept, so the x-intercept, you let the y be naught. So what would x then be?
X is now negative 2.
Okay, so we go to negative 2 and we write negative 2. So our line would have gone like this. It would have gone through like this. But now there's something very important before I draw the line. What would that be, Nelson? What's the important thing? What can x not be?
We're saying x is not equal to 2.
But now if x was 2 in this form, okay, what would the y value be? If x was 2, it would be 4.
Then y value would be 4.
Okay, so that would be 4. So at 2 and
at
4,
2
we've got a problem here. An open dot. Look at this. This is so important, guys. Watch this. In other words, at 4, we've got an open dot. Now, the line actually then does this. If you think about it, it goes like this to the open dot and goes like that.
Yep.
Okay, so this is the graph of this thing where x can't be 2, which is really a straight line graph where x cannot be 2. So there's an open dot there. So when you approach, in other words, the limit of the fx, let's call it fx there, this graph fx, as x approaches 2 is actually equal to 4. Do you see that there? It's 4. You approach it, but at that point, there's an open dot. So remember, it's what you approach. As you approach, if the x's approach 2 from the left and the right, the y values approach 4. This is a very tricky concept. It's the approaching, hey Nelson, of that. And if we go to the slide, let's just look at that again, and that's why we had to factorize. Do you just want to quickly revise that with them?
Right, let's look at this, guys. What we did, numerator here, we had to factorize it into x plus 2, x minus 2, and we divided x minus 2 by x minus 2. Then we got x plus 2. What happens now? Replace x by 2, you get 4. Remember, the main thing, you cannot start by replacing x because you'll get division by 0, which is not actually allowed. then you simplify it to x plus 2.
Absolutely. It's a very important thing. And when you do, say, advanced program mathematics, you obviously go into discontinuities, but we're not really worried about that. The important thing is to understand the limits. As the x's approach, the y values approach 4.
Yeah.
But if you look at the graph again, it's so
Because
important.
it's the red line
Yeah.
in itself.
This is actually a disguised version of a straight line, and then x can't be 2, so it looks like this. But remember, that an important that if I said to you what is the f of 2, that is undefined. Do you agree?
Yep.
Okay, it's totally undefined. Now, what we're going to do is we're going to take all of this mathematics, the limits, and something else in the next lesson further. So hang around, guys. We're going to come back and do some more divine calculus.
See you.